Why is it called sigmoid? Because it looks like the letter S. As input goes from negative to positive, output smoothly moves from 0 to 1.
Sigmoid outputs 0, 0 to 1, is smooth, differentiable, and monotonic. Perfect for binary classification. In neural networks, the sigmoid takes the weighted sum from previous neurons and converts it into a value between 0 and 1, like a probability.
But sigmoid has a deadly flaw. When input is very high or very low, the gradient becomes almost 0, causing vanishing gradient problem.
Advantages: easy to understand, gives probability output, and was the go-to activation function for many years.
Disadvantages: not zero-centered, computationally expensive due to exponential, and suffers from vanishing gradients in deep networks.
Use sigmoid in the output layer for binary classification. For hidden layers, prefer ReLU, leaky ReLU, or Swish. Classic but not always best.
Compared to ReLU, sigmoid is smoother but slower to train. That's why ReLU replaced sigmoid in most hidden layers today.